All right, so today we're gonna do a couple of things. First, I have some dad jokes. So instead of a story joke, I have 5 dad jokes today. Maybe I shouldn't record until after those are done. But I do have a spiritual thought. And then, let's see, Shara, could I have you say the opening prayer this morning?
Yeah.
Okay, and then we will dive right into chapter 7. So without any further ado, did you hear about the kidnapping at school? He woke up. I'm the fabric version of King Midas. Everything I touch becomes felt. My wife first agreed to a date after I gave her a bottle of tonic water. I swept her off her feet. I always used to get small shocks when touching metal objects, but recently it stopped. Needless to say, I'm ecstatic. Why do Swedes build their own tables? No IKEA. All right. Okay, now for something that actually matters. Oh man, where'd my window go? Oh, thank heavens. All right. So President Nelson in our last conference, one of his talks was titled "Let God Prevail," and he taught us that one of the meanings of the word Israel is "Let God Prevail." And anytime I think about gathering Israel, I think about missionary work, temple and family history work. I'll often think about raising my kids in the gospel and what that entails. But he said something really powerful in his talk. He said, the only way to survive spiritually is to be determined to let God prevail in our lives, to learn to hear his voice, and to use our energy to help gather Israel. So when he first said that the only way to survive spiritually, I'm like, holy cow, a prophet is about to say like how to survive spiritually and the only way to do it. And then he said 3 things: be determined to let God prevail in our lives, learn to hear his voice, and use our energy to help gather Israel. And so my invitation to you guys today is to choose to do that. Choose to obediently follow him, to let him prevail in our lives, seek to learn to hear his voice, and then use your energy to help gather Israel. Now, my energy, I miss going to the temple desperately. But thankfully I have all these like tiny little beings at my house that help me feel like I'm gathering Israel every second that I'm at my house. Whether that's true or not, that's kind of how I feel. But anyways, one other thing that he said at the end of his talk was, as you study your scriptures during the next 6 months, I encourage you to make a list of all that the Lord has promised he will do for covenant Israel. Ponder these promises. Talk about them with your family and friends, then live and watch for these promises to be fulfilled in your own life. I am just amazed anytime I actually study the promises that he made to Israel and to his seed. And anytime I go to the temple and I think about just how much the Lord is ready to bless us with, I'm just blown away. So I would just reiterate that as well. So, okay, Shara, go ahead.
Okay. Our dear Heavenly Father, we are so grateful for this beautiful day that we have to meet together as a class. We thank thee for Brother Birch and for his preparation and for the thoughts that he shares with us and for all that he teaches us. And we ask thee to please bless him and his family, and please bless that we'll be able to have thy spirit as we go throughout this class this day, that we'll be able to learn the things that we need to learn to help us to become better servants to thee and be able to serve those around us. And Heavenly Father, please help us to be able to remember the things that we've learned from our prophet and be able to apply them into our lives. We're so grateful to be here. We're so grateful for the love that thou hast shown us every day. And we say these things in the name of Jesus Christ. Amen.
Amen. Thank you, Shara. All righty. Let me share my screen real quick. I can't even believe we're in week 7 already. This is crazy. All right. Okay, can you guys see my screen?
Yep.
Awesome. All right. This is going to be a fun week. The things that you're going to learn in this week, you are going to use pretty much every single time you write a program for anything. So before I dive into chapter 7, were there any questions about chapter 6? Sweet. All right, chapter 7. We are learning about logic this week. So for a computer to actually seem intelligent, it has to be able to reason in a sense. Obviously, computers can't do that. They're incapable of it. But the way that programmers make it appear that computers can think is by using logic operators. Okay, so these are most commonly referred to as just like if statements. Okay, there are several others, but this if type logic is like the backbone of all logic. And basically what happens is you have an if statement and it's followed by a true false expression, what we call a Boolean expression. So a Boolean data type is either true or false. We learned about how to declare Boolean variables in week 4. And an expression in JavaScript will either equate to true or false. Okay, so if I say, right here we have this template condition 1, operator condition 2, and we have a couple of operators. So right here we have the not operator, we have an and, we have or, and we have an exclusive or. Okay, these if statements can have multiple conditions. So last week we talked about the relational operators and what those look like. Let me actually pull up my text editor here. All right. Okay, so last week, I'm going to go into chapter 6. I'm just going to pull up one of the programming assignments from last week. Actually, I'll pull up your actual assignment. Okay, so we had several if statements that we could have done. You could have done this as a switch statement. That would have been just fine. But right here, we have several of these conditional operators. So we have, if I was just going to read this in English, I would say, if weather type is equal to hot, else if weather type is equal to rain, or if weather type is equal to snow. And then I didn't have to have an else statement. We didn't have any condition for an else. Very frequently in an else statement, you would have put like a little error handler. If they said something other than these, it would have been, please enter, galoshes, boots, or shoes, or something, or rain, hot, or snow. But anyway, so this is just a very simple if, else, if block. All right. Some of the relational operators that we talked about last week, I would say, if, let's see, if I had like a variable called var child age, and we say it's 5 years old, okay, I could say if child age is less than 10, then I'm going to say message equals not ready for Harry Potter, or something like that. Okay, and so I can use any type of relational operator that I want to. All right, we talked about less than or equal to, greater than or equal to. We have is equal to, and then the other one is not equal to. Okay, so this check would just be like, is child age not equal to 10? If it's anything else but 10, then we would go into this message. Okay, now in here, right here, we're learning about ways that we can have multiple conditions. Okay, so right here, I have one condition. If child age is less than 10, well, maybe girls are more mature than boys. And so maybe I would say if child age is less than 10 and gender is not equal to girl, or something like that. Okay, I could have as many expressions in here as I wanted, all right, by using this and operator. So notice that this condition is just a single, basically, if statement condition. This by itself will equate to a true or false value. Is gender equal to girl or not? Same thing with this. This is a single condition, but thrown together, we have this like, this by itself is a condition, but it has two conditions that make it up. So at the end of this, it's either going to be true or false. It's still like an if statement condition, but it'll check all of like the subconditions in it to see if this will, in the end, equate to true or false. So let's look at a couple of examples. Before we do that, so we have our and right here. So if I was just going to read this in English, I would say, if child age is less than 10 and it's not a girl, then they're not ready for Harry Potter. We also have our or. Okay, so if I was going to change this logic right here, if I change this, now I'm saying that every girl can watch Harry Potter from birth. Okay, because now I'm saying this side of it doesn't matter. Okay, this or is saying if either one of these is true, then this whole statement is going to be true, and we're going to go into this if statement. Okay, so that's what the or does. The and would require both sides of it to equate to true for the whole thing to be true. The or, just one or the other. And then we have exclusive or. This one's interesting. This is what it looks like. And to be completely honest, it's not super common to see in the workplace, okay? Which is interesting because it's perfectly valid code, but you never have to use it. It's kind of like a switch statement, you know? If you want to use a switch statement, there are many times where you can, but more often than not in the professional industry, you'll just see if statements because everyone's used to writing if statements because they work with everything. I couldn't have like a multiple condition switch statement. It's impossible. The exclusive or is kind of similar. Okay, there are some cases where it works and many where it doesn't. And because of that, people usually just get used to writing multiple conditioned if statements instead of the exclusive or. But what this says is, you know, we had the and where both would have to be true for it to be true. We had the or where one or the other could be true, but also this would equate to true if the child was 5 and it wasn't a girl. I think I meant to do that. Oh, no, I did mean to do that. Okay, this would equate to true if either one of these was true or if both of them were true. Okay, the exclusive or, however, it's one or the other. So if both are false, this is false. If both are true, this is false. Okay, so exclusive or is one or the other, it can't be both. All right, and so we'll look at a couple of examples.
Real quick, I just wanted to clarify. So when like say like in our if statement there, we can we say like this and that to like have 3 things go in. But if we were to say this and that or this, would we be doing the second and third are the ors, or would or be from? Sorry if that's confusing. I was just thinking of that while you were talking.
Samuel, that's a really good question. And yes, it's confusing. So my answer is probably going to be confusing, but I'll do my best. Okay. All right. So what Samuel was asking is, what if we have 3 conditions and we have
that's that nastiness.
So I'm going to say if child age is less than 10, we'll worry about the exclusive or later. And gender is not equal to girl, or location is equal to...
I'm listening to a class meeting.
New York.
It's okay.
Deborah, I think I'm going to mute you real quick. Okay, so what would happen here? Right here, I have 3 different conditions inside of this if statement. Okay, child age is less than 10, gender is not equal to girl, or location is equal to New York. Let's actually say like Butte, Montana. Okay. Not that I have anything against Butte. Anyways, so what we're looking at though is what order will this take place in? Okay. So does anyone have a guess? Like what kind of a condition would make it so that this whole thing is true? What would these 3 variables have to look like for the whole thing to be true?
I wonder you have to have parentheses between child age and gender.
Yeah, that's a great thought, Yuri. So we can always add parentheses. All right, just like when I have a bunch of arithmetic and I'm like var volume equals 5 times 3 divided by 2 plus 6 minus 1. Okay, ironically, that actually is in the order of operations, but if I went like this, okay, you know, what's going to happen first is this 5 times 3. Okay, that ended up being 15. 6 divided by 1 would happen. And then we'd have 5 times 3 minus 2, and then we'd have the plus whatever 6 divided by 1 is. Okay, we have that level of precedence, that order of operations, if you will. Well, these relational operators also have a level of precedence. And so by default, if I have 3 conditions and they're separated by ands and ors, it'll just go left to right. All right, so it'd be like, okay, is child age less than 10? If yes, then we'll keep on going. Okay, then it'll see, is gender is gender not equal to girl? Okay, if that is true, then it'll check to see if both of these are true. Okay, and so the way that this will be separated by the or is either what I've highlighted right here has to be true, or the location is Butte, Montana. Okay, because it's really similar to arithmetic where we have that order of operations. The same thing here works with these relational or with these operators, these logical operators. Does that answer your question, Samuel?
Yes, yeah, that makes a lot of sense where you have these things or this thing.
Yes. So what I would say, if we're going to run this, let me copy this path and run it in our browser. Sometimes it's hard to remember what the order of precedence is for all of your logical operators and your arithmetic operators. Sometimes it's just hard to know what the order is. So what I really like to do is open it up in my developer tools and put a breakpoint in. So I'm going to hit my button. I really don't care about shoes at this point. We have child age, gender, and location. And then each step in here, I can actually highlight it to see what the entire thing will be. So if I just highlight this whole thing, we can see what it will equate to. I have to get the whole expression in there, and it says it's going to be true. All right. But I can look at this and I can see, okay, child age is less than 10. That's true. Gender is not equal to girl. That's also true. So I can see what this is together, okay, which will be true. All right. And then if I say, is location equal to Butte, Montana? That's false, but this side of the or is true. So if I look at the whole thing again, then it'll be true. So I love debugging these things because they can get really confusing. But Yuri really did make a good point that I can put in parentheses anywhere I want. So what would really change this is if I went like this. Okay, now, either one of these could be true. Okay, before this gender, it had to be not equal to girl for it to be true. But now either one of these could be true, just by me adding parentheses in there. Okay, so really parentheses can make you do exactly what you want with it. But sometimes it just takes a lot to just kind of think through it and be like, okay, what would happen if I put in an age of 15 for this instead of 5? How would that look? Let's actually try that real quick. So I'm going to take the parentheses off and I'm going to put 15 and I'm going to hit refresh. I'm going to hit my button. Okay, age is 15. All right. So first things first, if I highlight over this first expression or this first condition, it says that's false. Okay, now here we can test to see where this or is actually going to matter and where this and is going to matter. Gender is still not equal to girl. So if I look at this whole thing, it still comes up as false because now our child age is equal to 15. This side as well is also false. And so if I look at the whole thing, obviously that is going to be false. Okay, now let's look at one more example. Let's change this. Let's look at our exclusive or real quick. So I'm going to come over here. And I'm going to delete all that. Actually, I'm going to delete location. I don't like this location thing. I'm going to delete that. And then in here, let's go ahead and say that the child age is 5, and we'll leave gender as a boy. Okay, which means both of these will be true, but instead of and, I'm going to put an or. Refresh the page, hit my button. Okay, gender is boy, child age is 5. Is child age less than 10? True. Is gender not equal to girl? True. Okay, so the child is definitely not ready for Harry Potter. Now, let's change this up again. If I say that the child age is 15, okay, so we've got a 15-year-old boy coming in here, hit our button. Child age is 15, gender is boy. Is child age less than 10? False. Is gender not equal to girl? True. Okay, so one side's true, one side's false. So this entire thing equates to true. Okay, so hit F10, still not ready. Now, if I come back over here and I change this to, let's say it's not equal to boy. Okay, And I'm going to make this back to 5. All right. So if I run this right now, both of these are going to be true. And let's test it. Okay. Child age, true. It's less than 10. And gender, whoops. I'm going to change this back to girl. Sorry, guys. All right. Hit our button. And then is gender not equal to girl? That's also true. Okay. So both sides are true. If I hit F10, okay, child's not ready. All right. Now, if I change this to our exclusive OR, let's look what happens. I'm going to refresh the page. You can see it updated. And I'll hit my button. Child age is still 5, which is less than 10. And gender is not equal to girl. So if I look at this, both sides of this are going to be true. Okay. But what the exclusive OR does is it says one and only one can be true for this whole thing to be true. So if I highlight this whole thing, it will show false or 0. Okay, if I hit F10, you can see it skipped this. It didn't go into message because this whole thing came out to be false. Because exclusive OR will only be true if one and only one are true. Okay, any questions on this? Okay, well, let's keep going then. Okay. A program that reads a girl's age from the keyboard and determines which class she should attend. Okay, so let's look. I think I have this. Oh, that's week 6. Week 7, girls' classes. All right, so if we compare this with our table, let me close this real quick. All right, so we have, if the girl's age is younger than 12, then she'll be in primary. If it's 12 or 13, she'll be a beehive. 14 or 15, my maid. 16 or 17, Laurel. Okay, if we come over here and look, okay, you can see my logic. If age is less than or equal to 11, okay, now I could have just done is less than 12. That probably would have been better because now if somebody says I'm like 11.5 or something like that, this would still work. Okay. Otherwise, if the age is less than 14, okay, notice that I didn't have to say is equal to 12 or 13. This line of code right here would have worked just fine. Assuming we were dealing with whole numbers, this would have worked just fine. All right, but I simplified it a little bit and I said if age is less than 14. Okay, we looked at a similar example last week where we could simplify our logic because of a previous if statement. Okay, if I know that the age is less than 12, then we're going to go into here. If I ever reach line 17 in my code, I know that the age is not less than 12. So do I have to say that the age is going to be greater than 11 and less than 14? No, I can just say it's less than 14 because I already know it's not less than 12. So same thing right here. I wouldn't have to put age is equal to 14 or age is equal to 15. I could say age is less than 16 or age is less than 18. Okay, so there's lots of different ways that I could do these. And then else, all other ages 18 and above would be Relief Society. Okay. Any questions on this? It is nice having the option, you know, if you wanted to break it up. Some people would choose to do something like this. Let me put that there. Some people like to do stuff like this with multiple expressions just because it makes it easier to see at first glance. You don't have to logically think, oh yeah, this is saying ages 12 and 13 or, you know, because everything less than 12 will be in primary. You know, but sometimes people like to do this, even though it's more code, because it's really easy to see, oh yeah, 12 and 13-year-olds go to beehives, 14 and 15 go to my maids, you know, and a lot of that's just personal preference. But this is a good example to see how we could use this OR operator, because age could be equal to 12 or 13 and would go to beehives. All right, according to the Disneyland website, guests wishing to drive a car on the Autopia must meet one of the following height requirements. Either they're 54 inches or taller to drive alone, or they're 32 inches or taller and accompanied by someone who's 54 inches or taller. All right. A JavaScript program that accepts the height of a driver and an optional passenger and uses the logical operators or an and to determine if they may ride the Autopia. I'm thinking we should just code this real quick. So let me put this over here. Oh, it's really small. All right, I'll leave that here. And I'm going to make a new file, and I'm going to save it as an HTML file. And I'll just call this temp.autopia.html. And then in here, I'll use my little hotkey, well, kind of hotkey. I'll type an exclamation mark and hit tab. And here's my HTML document. And I'll say the title is Autopia. And let's start with our defining table. This is similar to something you'd have in like a test. So I'm going to have a multi-line comment with an input, processing, and output. Okay. Anyone catch what our input's going to be? Let's check it.
No height and how many typers, like how many people want to.
Okay. Yeah. So let's say we'll have height of person A and potentially height of person B. Okay. Well, we'll say height of rider and height of passenger, which is what I think the website said. Okay. And then what's the output? Let's look over there real quick at what our output is. The program outputs either enjoy the ride or sorry to drive on this. The user must be that tall. Okay, so we'll say either enjoy the ride or sorry, you need to be at least 32 inches with passenger 54 inches to ride. Does that sound okay? Okay. All right, processing. What kind of processing, what kind of logic are we going to have to do here to be able to get from our input to our output?
We're going to need to use, we're going to need to know, because one of them, no matter what, has to be taller than 54 inches. So that'd be like an and state, or like this or that would have to be taller than 54 inches.
So if I was just going to tell you in English, you know, one simple way that I could tell you is, you know, if the rider is 54 inches or taller, they can ride by themselves. That is one condition that we'd have to have, right? So right here, I'm just going to say, if rider is greater than 54 inches, they may ride. Okay, what's another condition that we'd have to have in here? If rider is greater than 32 inches and passenger is greater than 54 inches, they may ride. Else, they can't ride. Is there anything else that we would need? Okay, so the way that we have it written here in our defining table would be like an if, else block. Okay, so we're going to try to write it in two ways. We're going to try to write it like this, and then we'll also try with just a single line of code. So we're going to say this input has an ID of rider height, and this one has one of passenger height. Okay, there are our inputs, and I'll just say, please enter rider height, and we'll have a break here, and please enter passenger height. Okay. And then let's actually put another break here, and we'll have a button, and we'll say on click, check height. Last thing, we'll just need an output div for our message, and I'll just leave an ID of output here. Okay, questions on the HTML part of our program? Okay, then let's come in here, and we called our function check height, and we will need our input. So I say document dot get element by ID, and we have rider height dot value. Okay, that's one of them. The other one of them is passenger height. Both of these we're going to have to assign to a variable, but we're also going to have to parse into numbers before we can use them. So I'm going to hit Control Alt down arrow to put a cursor on the line below. So I have a cursor on both lines. And I'll just say parse float, end line, add a parenthesis there. And I'll say var, I'll say rider equals that. And I'll call this one passenger. Okay, so there's our input. And then we'll have output after the processing. Let me put processing right here too. I always just start with input, then do output. And I'll say document dot get element by ID output dot inner HTML equals message, which we need to declare. Okay, so var message equals, and what we're going to do here, let's go ahead and let's just have like a default value. So we'll just say enjoy the ride. Well, let's have our other message actually. So we'll put this message here. Okay. And now all that will do is just save me a line of code. Okay. I could have an else statement that says else and then assign this, but either way I have to declare message beforehand. So I might as well just declare it with the default value. And then we'll change it to they may ride if a condition is met. So we'll say if rider is greater than 54, then message equals you may ride. Okay. The other condition that we would need here is if rider is greater than 32 and passenger is greater than 54, then message equals you may ride. Okay. Now, I could have done this as an else if statement. That would have been just fine. But like this, I'm pretty sure our program will work. Anything you guys see that we should change before we try to run it? Okay.
Yeah.
Oh, go ahead. Go ahead, Carolyn.
On click doesn't have a K.
Good catch. Nice work. Okay.
I'm a
Wait.
spelling nerd.
Well, that's a really good skill to have in the programming world. Okay. Anything else?
Can I ask a question about the button?
Please. Yeah, please.
Some of them it says the button and it says button equal quotation button.
Yeah.
When do I have to do that?
Never. Yeah. So there are some things in HTML that you have to have. You know, some of this stuff in here, like this UTF-8 will happen by default. This language English will happen by default in my browser. But if I was in like a super old browser or, you know, a browser that wasn't supported anymore or something, then it would need to have these. It wouldn't have these by default like it would in Google Chrome. This button type button is the default for HTML5. So you never have to put that type button here if you don't want to. So, good
Thank
question.
you.
Yeah. Okay, any other questions before we run it? Okay, so let's run it and see what happens. I'm gonna copy the path, open up a new tab, paste it, and rider height, let's just go on the safe side and say they're 55 and that's 0. Hit our button, it says you may ride. Okay, so that worked. We need a label for our button, I think. Let's test our other condition. Let's say we have like a 4-foot child and is that 6 feet? No, that's 6 feet. Okay, and a 6-foot tall person, we'll run that and it still says you may ride. If we bump this down to 48, we have 2 kids that are 4 feet tall. Okay, so I think our little program here is working. Now, let's use our newfound knowledge of this and let's try to combine all of this. Okay, real quick, if we didn't want to use this and, could we still do this? If we didn't have any of the and or operators, could we do this?
Yes.
Okay, what do you think, Samuel? How could we do it?
So it'd just be really, because you would have to nest an if statement inside of it, right?
Yes. Yeah,
And
so
it'd
we
just
could
be
do it.
messy.
Yeah. So if I take that out, and if I say, if the rider is greater than 32 inches, then we'll check to see if
Yes.
the passenger is greater than 54. Okay.
Then it will finally mess.
Now, there's a couple of issues with this. One is, well, I guess so we already declared that the default is they can't ride. So even if we didn't have an else statement right here, we would still have, sorry, you need to be at least 32 inches to ride. So this would totally work. Now, I don't know of anybody who likes nested if statements. Okay. This would work. We could test it real quick. Let's try it. Hit F5. And we'll say our rider height is 48 again. And we'll say they're both 48 inches. It says, sorry, got to be taller. If we had one that was 60, it says you may ride. And if we look over here in the source, you can see we have our nested if block here. Okay, so it did work. It worked just fine. Now, let's clean this up a little bit. A minute ago, we had one of these operators that did this. Okay, now what we're going to do is, our logic here is if this is true or if this is true, right? So I'm going to copy this. And I'm going to put an or right here, and I'm going to paste it. Now, based on order of operations, I need some parentheses, because otherwise it's going to say if the rider is greater than 54 inches or the rider is greater than 32 inches. Okay, that's not the logic that I want. I want if the rider is greater than 54 inches or the rider is greater than 32 and the passenger is greater than 54. Okay, so I put some parentheses in there to say this is what it has to be. Then I could delete that and save it. And now let's try running this again, and let's see if it works. So I'm gonna refresh. I'm gonna put a label on our button real quick. That's driving me nuts. Okay, and we'll say the rider's 48 inches. They're both 48 inches. And I'm gonna put a breakpoint right here, and we'll hit check height. Okay, is the rider greater than 54? I can highlight this and run it, false. Okay, we have an or statement here. So as long as this equates to true, then we're good. It equates to false. But if I look at rider is greater than 32, that's true, but passenger is not greater than 54. So because one of these is false, this equates to false. And because both of these are false, this whole thing will equate to false. And if I just hit F10, then our message remains as our default, which is sorry, you got to be taller. All right, let's try it again. Let's have a passenger height of 60. And we'll run our function again. Is the rider greater than 54? False. Is the rider greater than 32? True. Is the passenger greater than 54? True. So I'm going to check this whole thing in parentheses here. It says true because this is an or statement. If I check this whole if statement, it'll say true. And if I hit F10, it'll say message, you may ride. And there we are. Okay. So if you look at this, compared to our if, else, if, or if with a nested if statement in there, this makes me really grateful for these operators. Okay, it might take a little bit to get used to them, but it's so much cleaner. And I don't have to worry about a billion conditions with else statements that I have to meet, because this has all my logic right here. It's like, okay, if this is true, you can ride. If not, you can't. Okay. Any questions about this?
So I remembered a question I had about last week's assignment.
Yeah.
All right, I saw it. I can't remember whose website I was looking, since like I take their code and I look at it to like make sure it runs and everything.
Yeah.
Somebody had code and they had inside of their text tabs, I couldn't figure out how they did it, but inside their text tabs, they had the text written in there. Like instead of please writer's height, they had it inside the tag, like inside the box. How did they do that?
I will show you. It is an attribute of the HTML element input. So right here inside of my input, if I put a placeholder attribute, watch what happens. I'm going to save that, come back over here, hit refresh, and now you can see inside of my input, that's there. Okay. So it's
Okay,
as simple as just having a placeholder attribute on your input.
placeholder equals.
Yeah.
Okay.
Yeah, great question.
I was like, how are they doing that? And then I remembered when you put the button inside and the button said something. I was like, all right, somebody did that with the input. And I was,
Yeah. It looks a lot cleaner. As long as my
Yeah.
inputs are long enough.
well,
If I was
especially
gonna, oh, go ahead.
last week with the math, like, please enter in a number or then operators.
Yeah.
Had like so much code or like so much text that could have just been put in the box.
Seriously. Okay. So we could adjust any type of style here we wanted. This just made the width of this input go to half times again the length of the width of the entire page. So if I wanted to take up like, let's say I wanted to take up 33% of the width of the page, I'd probably want this other input to do the same. And I would probably want this whole thing to say text align center. Okay, so we'll go ahead and center everything inside of the body. And then each of these inputs are going to take up a third of the page. If I hit refresh, it's looking a lot better. Now, there's a better way to do this. These are called inline styles. And you can see I have a little bit of code redundancy right here, which I don't like. Okay, if I wanted to change one, I'd have to change both. Inside of my head tag, I can put a style tag. And if I just put the name of an HTML element, then it will apply to all of them. Okay, so input, I'm just going to say width of 33%. And body, I'll say text align, text align center. Okay, then I can take this off of here. I can take both of these off of here. And let's run it again. You can see it still worked. Okay, if we come over to our elements, you can see inside the head, we have our style tag now with these. And we don't have any styles written on these, which is nice because it keeps these clean of style. And then we could have as many styles as we wanted up here, and that would be just fine. So one other thing, since we're talking about style, that we might want to add with our inputs is just to say like margin, maybe we say like 10 pixels. What this will do is it'll add 10 pixels of space to all four sides of an input. And so if I run it again, now you can see I could take my breaks out. I will, you know, I guess I would still need one to get them on a different line. But yeah, so. Okay.
So with using breaks, are breaks HTML or would it be considered CSS?
Breaks are HTML.
So breaks are HTML. Those should be used when needed. Okay.
Yes. Yeah. If I wanted to though, oh, maybe I can't do that. Oh, that's why. So it is an HTML attribute, and I could actually put CSS on here. And if I did that, it looks like it's not doing it. But yeah, break is an HTML attribute or element.
Okay. Okay. Well, thank you for answering my questions. I was just confused why their websites look so much better than mine. So
yeah, placeholders can help a lot. So all right, and it's interesting too. Just a couple minutes with CSS really make a difference. You know, even just centering this on the page and giving them a little space, it makes a big difference. All right. Okay, exclusive or. Okay, let's go into this. Let's see. We have 15 minutes left. Is that right? I think that's right. Okay. Here's a small programming example from a program that includes buttons in its user interface. So you could kind of think of this as like a light switch. So this code is used to enable or disable a button. All right. So lots of websites, when you're filling out a form, for example, I actually just did this with my bank account the other day. So I went to make a transfer from one of my accounts to a different account. Okay. But I could not click on the button, like the submit button, until I had like a from account chosen, a to account chosen, a dollar amount chosen. The memo was optional. Okay. But once I had those 3 required fields there, all of a sudden I could push that button. It was enabled. Okay. So right here, we're talking about enabling and disabling buttons. which is really important because pretty much every website has something very similar to this. I just gave you a bank example, but it's super common. Anytime you log into a website, lots of times you won't even be able to hit the login button unless you've put all your credentials in there, your email and password usually. Some websites, they'll have an error check. You can click it, but then it'll say invalid credentials or something. So there are multiple ways to handle it, but it's very common having to enable or disable the button. So let's look at the logic here required. So I could say if is enabled is equal to false. All right, so if it's not enabled and the user command is to enable it, then we'll go ahead and enable that button. Else if the button is enabled and the user command is to disable it, then we'll go ahead and disable the button. All right. Now, there are more simple ways to think of this. I could think of this as simply as if it's enabled and the user clicks it, then it will disable it. Or if it's disabled and the user clicks it, then it will enable it. But let's look at this example down here. Notice that the code example does nothing if a button is already enabled and the command is to enable the button. Okay, the logic that we have here is very specific. Either the button is enabled and the command is enable, or the button is enabled and the command is disabled. Okay, so anytime we have that type of coupling with logic, where we could just easily say either or, then we could use the exclusive or operator. So if is enabled equals true, exclusive or the command is enabled. Okay, because those two, is enabled and the command being enabled, will never happen at the same time. Okay, it'll either be one or the other. And so this will allow me to toggle the button with a little bit less code. And so this line of code right here with the exclusive or, sorry, I'll stop moving my mouse there. This is the exact same logical result set as our if else if statement up above. Okay, and we already looked at one example of the exclusive or. What I would recommend, I won't go too much into exclusive ors because like I said, people don't usually use it. Okay, yes, it's out there. Yes, you have to understand what it does. But anytime I'm doing anything with it, I just go to the developer tools and I like run it and test it and make sure that the logic is what I want it to be. So it's important to understand because in this class you will be tested on it, but you'll never have a test in this class where you can't use the developer tools, where you can't run code. You know, I won't ever try to just like trip you guys up. Okay, if you see a test question about the exclusive or, just run it with the debugger and check it. Any questions about these bits of code? Okay. All right. Oh man, logical equivalences. So this is a screenshot out of your book. All right, and I left a little note here. Don't memorize this. Okay, just use it to practice, and then never think about it again. So it's important to understand that they exist. Similar to earlier when we wrote that same program for the Autopia ride in like 3 or 4 different ways. There's lots of different ways to write it. Okay. For example, if I was over here, let's see here. So we have if rider is greater than 54, or if this. Well, I could change this. I could say is not greater or is not. Let's see here. So it was if rider is greater than 54. I could also say is not less than 53. Okay, that would be the same type of logic there. Okay, so I can switch things around. What that would look like is rider is less than 53, and then I would have to negate this whole thing. Now, for this not to negate my entire if statement, I'd have to put that in parentheses. Okay, so right here, this would run exactly the same way. As long as I have that there, otherwise we would have missed 53. Okay, so if the rider is not less than or equal to 53 is the exact same way as saying if the rider is less than 54. Okay, so I just like negated the opposite logic. Okay, I could do the same thing over here, except sometimes it makes my brain hurt. Okay, but the principle of the matter is that there are all these laws. Okay, we probably heard about these laws back in like 5th or 6th grade when we were learning math. And they're like, oh yeah, there are these distributive laws where if you multiply one, you have to multiply both. Okay, and so there are all these different laws, and it's important to understand that they exist. Okay, because I could write the same piece of logic 10 different ways, and get the same result set out of that piece of logic. Okay. My brain usually works better. Like the simpler, the better. We had the if, else, if block with the nested if statement in here. And I'm like, yeah, I'd rather do this. A second ago, we said, we could also write this like that. Is not, hang on, is not greater than or equal to 54. That's what it would be, okay? Because this is saying, oh no, it would be less than, sorry. Anyways, so when I try to do this, usually it just complicates things for me. It's just important to understand that there are many ways to do this. And you could rewrite this pretty much any way that you want to. When I'm doing it, similar to like with the exclusive or, I'll just test it, and I'll test it with like a bunch of different inputs and make sure that I'm outputting what I want to output. Just like we did with the Autopia ride. Okay, when we were testing this, we tested values below and greater than, lesser than and greater than 54 for the rider and passenger to make sure that, you know, our code worked. All right. Okay, so questions on this. Okay, if you look at this in the book, basically, you know, it's saying A or B is the same thing as B or A. A and B is the same thing as B and A. You know, and it just kind of goes through all of them. So, all right, using De Morgan's law. We are going to talk about this just for a sec because it will show up on an exam. So here's the example. Well, basically, De Morgan's law is always just using negation, the principle of negation. And so this example is the dean of your college asks you to write a program to print a list of students who are not on the dean's list for academic excellence. So anytime I have something where I'm like, all right, I want to get all the people who can ride this ride that are not shorter than 32 inches or something like that. I would just say is not rather than is, you know, the people can ride if they're greater than. So right here, I could see that these people are on the dean's list if they have a GPA of greater than 3.5 and their credits is greater than or equal to 32. All right, if I negate this entire thing, that gets me everyone who's not on the dean's list. Or it gets me the result or the opposite result set. Okay, if I go back to this code right here, let's say right here, I put this message right there. Okay, if I just negate this entire thing and I put parentheses around it and negate it and paste that, it will do the exact same thing. The exact same thing, because I swapped my messages and then I negated this whole thing. So what was true is now going to be false. And what was false is now going to be true because of that single exclamation mark and parentheses. Okay. But that's basically De Morgan's law, is like getting the opposite result set using the principle of negation. Okay. Advanced word search. So let me actually click on this link. I don't know if you guys have ever done this, but Google is fantastic. Okay. There have been times where I wanted to find like a PDF of something. I was looking for like an instruction manual. I'm like, I don't want to manufacture a website. I want an instruction manual. And I could come into here and I could say, oh, file type, PDF. That's what I want. And all the results in Google are going to show PDF. Okay. Well, the logic that goes on behind this in generating this result set by Google is exactly what we're looking at today. Okay. With just a very large collection of this type of logic. All right. Let's look at an example. Right here. If I told Google that I wanted to find something with the word Madison, with either the word county or parish, and it had to exclude Idaho, which I could do, okay? The JavaScript for that would say Madison and, because it has to have Madison, it would have either county or parish, and it can't have Idaho, okay? And that would give us that result set. And that's how Google works, okay? Any questions on this? Okay. All right. Second example. Look on the internet to find a small flatbed trailer to purchase in Southeast Idaho. Craigslist is a good place to look for advertisements selling a trailer. Unfortunately, there isn't a single category for trailers. Instead, trailers are listed in the bikes, cars and trucks, farm and garden, motorcycles, and RVs categories. Take too long to search all of them, so use Google to do the search and restrict the search to Craigslist and East Idaho. At Craigslist, click Idaho, then East Idaho, and notice the domain is eastidaho.craigslist.org. At Google, use advanced search with the following criteria. So we could say in Google, we're going to look for flatbed trailer. We'd have not gooseneck. Okay, so this is like a minus gooseneck, and the site has to be eastidaho.craigslist.com. Okay, which will cause Google to search for advertisements posted to Craigslist to sell a flatbed non-gooseneck trailer in East Idaho. We could write this in JavaScript saying flatbed and trailer and not gooseneck, and the site is equal to this URL. That would actually be wrong. This would have to be a string in quotes. Okay. Okay, any questions on this example? Okay, it's fun to play with. Truth tables. Let's see, we got 2 minutes left. We create a truth table by considering 2 or more conditions. So if GPA is greater than 3.5, balance is greater than 100, maybe represented as B. With only 2 conditions and both having a true or false value, then there are only 4 outcomes. Either both are true, either both are false, or A is true and B is false, or B is true and A is false. Okay, those are our 4 outcomes. And I could look at this in a table. These tables that you see in your book blow people's minds a lot of the time the first time they look at them. But here's what they're saying. Okay, we have 2 variables that we're looking at. Each of them show all of their possible outcomes, false or true, false or true. And then right here, if I negate A, here's what our result set would be. Anytime A is false, it'll be true. It'll equate to true if I say not A. If I negate B, anytime B was false, then this will be true. If I put not B in an if statement, then that would equate to true if B was false. If I say A and B, both have to be true for this result set to be true. If I say A or B, then as long as they're both not false, then the rest will be true. And if I say A exclusive or B, then this will only be true if one or the other is true. So that's what these truth tables are for in your book. And so it shows, you know, given if A is false or B is false or one's true, you know, what this is on the left side, it'll show what it would change to if inside of our if statement, I was like, not A, not B, A and B, and so forth. So, okay. Any questions? I know we're about out of time.
I have a couple of questions if you have time, or I can email you instead.
Yeah, you can go ahead and ask them. I got a minute.
This week homework is using a computer clock, so you don't enter the input.
Yes.
How can I check that? Like, say that, you know, question is like a Monday, Wednesday, Friday, and if I'm on Tuesday and I can't check on a Wednesday.
So let me just grab some code. This is on W3 Schools. Okay. I'll just grab this. Okay, so in here, what was the function? So if I said like var, I'm trying to think of what some of the functions were. So like day of week, do you guys remember what that function was? Let me see. JavaScript get weekday, which will be a number. Oh, it's just get day. Okay, that makes sense. So notice we're making a date object, which is like a date data type. And then inside a date, I can run my get day function. So right here, I'll say d.getDay. All right, now let's run this. So I'm going to copy the path. I think I might have closed it and paste it. Oh, I didn't do it right there. Okay, and I'm going to run my function. We don't care about passenger height anymore. Oh, we have an error. Forgot an equal sign. Sorry, guys. There's even red. All right. So I put a breakpoint in there and I check height. Here's how I would do it. Okay. So I have my date object. Okay. Monday, October 26th, 12:32. If I hit F10, here's my day of week, day number 1, Monday. Now, if I wanted to test this for something else, what I would do is just temporarily, I would either like copy and paste this line and comment out one, and then I would say, okay, I'm going to force this to be Friday. Okay, and then I'll see, you know, when I run my if statement down here, I'll see what happens when this is Friday. Or if I have var time and I say time is actually, you know, 1500 or something like that, instead of a time of day that we originally had, I would just put in some temporary code right here to test it and then take it out once you know that each condition works. Does that help, Yodi? Okay, awesome.
Thank you.
Yeah. Okay, any other questions, you guys? Okay, it's great having y'all here. Have a great week.
Thank you.
Thank you. See you later.
Thank you.
Thank you.
Yeah, bye, guys.